Here are the answers for Lesson 8-2, Day 1. These questions are from page 356. They're the oral exercises 1 through 35 odds. The first several questions use this coordinate plane with all of these graphed points. Now look at the axes and notice that the labeling is counting by twos. The origin is in the center, and then the next labeled numbers go 2, and then 4, and then 6, and so on. So the odd numbers are being skipped, but it's important to realize they're still there. So this spot right here along the x-axis, which is 1 unit to the right of the origin, is 1. Here's 2, here's 3, and so on. That's true going up, down, and left. So on the x-axis going to the left, 1 unit to the left of the origin is -1. Here's -2. Here's -3, and so on. Going up the y-axis, 1 unit above the origin is where 1 is. Here's 2. Here's 3. Here's 4, and so on. And counting down would be your negative values on the y-axis. So 1 unit below the origin is -1. Here's -2. Here's -3, and so on. Now, question 1 is the ordered pair 2, 4. One of those red dots in the book is located at that spot 2, 4. The first number in the ordered pair is the value of x. That's where you go on the x-axis. The second number in the parentheses is the value of y. That's where you go on the y-axis. And what you're looking for is a point on the grid that has that x-coordinate and that y-coordinate. So here's where 2, 4 is. Along the x-axis, find 2. So you start in the origin, go along the x-axis over to +2. Then go up 4 units. 1, 2, 3, 4. That's point W. Point W, this spot right here, has the ordered pair 2, 4. So for question 1, it's point W. Now question 3, the first number is the value of x. That's where you go on the x-axis. And the second number is the value of y, where you need to go on the y-axis. So on the x-axis, -6. So starting at the origin, find -6, which is to the left. Here's -6. Now the second number is +3. That means to go up 3 spots. And you end up at point U. So point U is the location, -6, 3. So problem number 3 is point U. Now problem 5. The value of x is 9 and the value of y is 6. So on the x-axis, go to 9. The origin's in the middle. +9 is right here. Now the second number is +6. 1, 2, 3, 4, 5, 6. And that's point H. So point H is at the location 9, 6. Number 5 is point H. Okay, number 7. The x value is 0. The y value is -9. You start at the origin. Now the first number is 0, so that means stay at 0 on the x-axis. The second number is -9, so find -9 on the y-axis. That's down, all the way down until you get to -9. And we can see that that is point P. So number 7 is point P. Now number 9, this one's real similar, but this is 0, +9. So on the y-axis, all the way up to 9 is point I. And now number 11, -11, +4. So start at the origin. The -11 means to find -11 on the x-axis. That's to the left. Right there is -11. Now the second number is +4. That means to go up 4 units. 1, 2, 3, 4, and we're at point R. Okay, now number 13 is asking What are the coordinates of point M? So look around on the picture until you find point M. Here it is, in the top right quadrant. Now, what is the location of point M? Along the x-axis, how far to the right of the origin have we traveled? It is 5 units to the right of the origin. Now, what is its height on the y-axis? It's lined up with the 9. So the second number in the parentheses is 9. So the coordinates of point M are 5, 9. Now question 15, find point D. Here it is, the top left quadrant. Now what is the ordered pair? What are the two numbers in parentheses that give that location? Along the x-axis, you have to go to -9. And then, how far up do you go? To +9. So that location is -9, comma, +9. Left 9, up 9. Number 17, find point E. Here it is. Point E is on the x-axis at the 5th mark to the right from the origin. So its location is 5, 0. Right 5, up 0 units. Now point G. Look around until you find point G. Here it is, in the bottom left quadrant. What is the x-coordinate of point G? And what is the y-coordinate of point G? So from the origin, left to -9. That's the x-coordinate. Now, how far down to get to point G? It's at the height where -6 is printed on the y-axis, and so its y-coordinate is -6. Now the directions for the next set say, describe the graph. What does the graph of this equation look like? X equals 2 is a vertical line intersecting the x-axis at 2. Now, that's what you're asked to write out, is the description in words. So there you see it in blue ink. Now, what does this picture look like? So making a quick sketch, if that's your x-axis and y-axis, what do I mean by a vertical line intersecting the x-axis at 2? It means you find 2 on the x-axis, the second mark, and it would be a vertical line going through that mark. Now in the directions, you're not asked to draw it. You're just asked to describe it out in words. Number 23. What about the equation x equals 0? What does that look like if you graph that equation on a grid? It is a vertical line intersecting the x-axis at 0. This is a special vertical line. This one has a name. It's called the y-axis. All right, here's what it would look like if you had to do this. So here's a y-axis and x-axis. 0 is right there at the center of the graph. And when I say it's a vertical line tracing the y-axis, I mean that you would take your pencil and actually draw right on top of the y-axis. Now, number 25. What does the graph of the equation y equals 4 look like? This is a horizontal line intersecting the y-axis at 4. Here's what I'm describing. Here is a x-axis and y-axis sketch. On the y-axis, 1, 2, 3, 4. There's where 4 is. And a horizontal line goes across the paper. This blue horizontal line is what the graph of y equals 4 is. Now the next set, here are the directions. Give the coordinates of two different points. First, we're asked for the point where the line crosses the x-axis. This has a name. This is called the x-intercept point. The x-intercept point is going to have an ordered pair, and because this point is on the x-axis, the y-coordinate of the point is always going to be the number 0. So when you're asked to figure out what the x-intercept is, you're looking for an ordered pair, so two numbers in parentheses with a comma between them, and the second number is going to be a 0. Now the second thing we're asked for is the point where the line crosses the y-axis. This one's called the y-intercept point. It's going to have an ordered pair. But because it's a point on the y-axis, we know that its x-coordinate is going to be a 0. Okay, so let's do this. For each question, we have to find two different points. One of them is called the x-intercept. The other one we have to find is called the y-intercept. To find the x-intercept, the value of y is 0. So you take the equation, and where the letter y is, fill in 0. This creates a new transformed equation that no longer has the letter y in it. So now we're going to solve this equation. This makes 2x is equal to 10. Therefore, x has to be equal to 5. And so our ordered pair for the x-intercept is 5, 0. Now we'll get the y-intercept. The y-intercept is a point that's on the y-axis. Every point on the y-axis has an x-coordinate of 0. So take the equation, and where the letter x is, substitute in 0. Now solve. 2 times 0 is 0, so 0 plus y just makes y, and we're left with y equals 10. So as an ordered pair, when x is 0, the value of y is 10. This ordered pair is called the x-intercept, and this ordered pair is called the y-intercept. Now number 29, same directions. We're going to find 2 points on the graph of the line. One of them is called the x-intercept point, and the other one is called the y-intercept point. Now, to find the x-intercept, what letter do you fill 0 in for? You fill in a 0 for the letter y. So 6x plus 4 times 0 is equal to 24. This makes 6x is equal to 24. Therefore, x is 4. So as an ordered pair, the x-intercept is 4, 0. Now let's get the y-intercept. What letter do you fill in a 0 for when you want to get the y-intercept? You fill in a 0 for the x. This means we have the equation 4y equals 24. Therefore, y is equal to 6. So as an ordered pair, when x is 0, y is 6. This is the x-intercept, and this one is the y-intercept. The final set of questions has these directions. Classify each equation as. Now we're given 3 choices. The first choice is, it could be a linear equation that's in standard form. The second choice is, it could be linear, but it's not in standard form. And the third choice is, it's not linear to begin with. So number 31, what kind of equation is this? Nonlinear. Here's the reason. The exponent on the x and on the y is not a 1. Do you remember the section in which we studied negative exponents? Negative exponents are equal to reciprocals. When we have the letter x in the bottom of a fraction, you can think of that as being x to the negative 1 power. 2 times x to the negative 1 power is the same thing as 2 over x when you move the x down into the bottom and give it a positive exponent. Similarly, the 3 over y is the same thing as 3y to the negative 1 power. This is not a linear equation because the exponents on the x and the y are not ones. Now number 3. This is a nonlinear equation as well. And for the same reason as in number 31, because the exponent on the x and the exponent on the y are not 1. Now number 35. What about this one? This one is a nonlinear equation. Well, you're thinking, well, how come? The exponent on the x and y are both 1s, right? Yes, that's true, but the degree of this single term is degree 2. When we learned about polynomials and monomials, and we learned about the degree of the terms, we learned that the degree of a monomial is the sum of its exponents. 1 plus 1 is degree 2. And an equation that has in it a term of degree 2 is nonlinear. So coincidentally, all of these odd number problems were nonlinear equations. So that begs the question, what would a linear equation look like? A linear equation has terms that are degree 1 terms. That is, there's a variable, and the variable goes to the first power. For example, 2x plus 3y is equal to 8. That's linear. Because the exponent on the x is 1 and the exponent on the y is 1, these are separate terms and the degree of each term is 1. Another example, y is equal to 1/3 x take away 5. This is linear. The degree of the y term is 1. The degree of the x term is 1. In my first example, this linear equation is in standard form. And in my second example, the linear equation is not in standard form. They're both linear equations, but they're not written in the same format. A linear equation in standard form has both variables on the left side of the equals. So in my first example, to the left of the equals, you see the letter x and the letter y. That's standard form. But in my second equation, here's the equals, only the letter y appears on the left side of that equals. So that's not standard form.